Problem number 1. 5 squares are inscribed along the hypotenuse of a right triangle as shown below. If AB is equal to 3 centimeters, alright, let's mark that on here. So this is 3 centimeters along here. And BC is 6 centimeters. 6 centimeters from B to C. What is the combined area of the 5 squares down here? Alright. Well, let me give you a hint on this one. First of all, you need to know the Pythagorean theorem. Okay, so the Pythagorean theorem. Okay, that just says that for a right triangle, let me just draw an arbitrary right triangle here. Where I said that a right triangle just is a triangle with a 90-degree angle. Then the sum of the squares of the two legs, let's call them A and B, is equal to the sum of the hypotenuse squared. So it's A squared plus B squared equals C squared. Okay? So if you know two sides of a right triangle, you can figure out the third side using this equation. Okay, and then the other thing is a little bit tricky in this problem. You have to look for similar triangles. Okay, so similar triangles. Now, similar triangles are just triangles that where the angles are all the same and the sides are proportional. Okay, so same angles and proportional sides. Okay, so what does that mean, proportional sides? That just means that the ratio of the sides is the same. So if you have one triangle that looks like this, where this side is maybe 1 and this side is 1.5, and you have a bigger triangle that's similar, pretend that's similar, and this side is 2, then if these are similar triangles, then this will be 3, right? So the sides are proportional, so the ratio of the sides is the same. Okay? So now in order to show that triangles are similar, they have to be this. Well, there's a number of different ways you can show that triangles are similar. You can show that two angles are similar, or sorry, two angles are equal. Or let's see, you can show that that two sides are proportional and an angle is equal. Or let's see, what's the other one? SSS. It's to show that all the sides are proportional. Okay, so there's three common ways. There are other theorems too, but these are the three main theorems to know. So angle, side, angle, side, and this is there's another one for congruence too, but this is for similarity. And side, side, side similarity. Okay. All right. So, probably another good thing to know is the theorem for parallel lines. And so if you have two parallel lines, okay, pretend these two lines are parallel, and you have a transversal, so it cuts across these two parallel lines, then you know that the corresponding angles are the same. Alright? If these lines are parallel, and oftentimes you'll mark them like this so to show that indicate that those are parallel. So the corresponding angles are the angles that are kind of on the same side of the parallel lines. Okay? And you can imagine, you know, if you just slid this second line up to the top, these are considered corresponding angles. And then the other theorem, and you could probably see this easily, is that alternate interior angles, sometimes it's abbreviated AIA, are also equal. Okay, and you can see that because if corresponding angles are equal and vertical angles are equal, then it implies that the alternate interior angles are equal. Okay, so we need to apply those. We need to apply these things to this figure. And these are my hints. These are the things that are that you can use to solve this problem. All right. So we know these are squares, right? Across here, we're told that they're squares. That means that all their sides are the same. And I'm just going to call this side x. I don't know. Just call the side of any one of these x. Okay, so that means also this is x, and this is x, and this is x, and so on. And we can figure out the length of this side, this AC, by using the Pythagorean theorem. So we can find the side AC is equal to a squared plus b squared, so that's 36 plus 9. And remember that's AC squared, so if we take the square root of it, then we'll get just AC. So that's going to give us the square root of 45, or if we take, it's 9 times 5, so 45 is 9 times 5, so if we take the 9 and take the square root of that, we can put it outside, so it's 3 times the square root of 5. Okay? So that length from A to C is 3 times the square root of 5. Alright, so that's just something we can figure out. How can we use that? Now I said that you'll need to use similar triangles. And you can see here, well, these are squares, so these are also right angles. Any of these in here are right angles. And you can see here that the triangle ABC and this triangle here starting at C and going in here. Let me see if I can, maybe I'll highlight it or color it for you. This triangle here, you can see that they share an angle here, right? And they both have a 90-degree angle here. So these two triangles, ABC and this green one that I shaded here, have to be similar, okay? Because we've shown that two angles are congruent. So the whole, so this triangle has to be similar to this big triangle on the outside, okay? Because if two angles are equal, then all three of them are really equal. And so the sides have to be proportional. And we know these sides, it's, the long side is twice the short side. And if we call this side here, if we call this side x, okay, and we know that the sides are proportional, then the length of this side is twice that, because these are similar triangles. So if the ratio of this is 6 to 3, then the ratio of this to this is also 2, so this is 2 times x, okay? So the length of this side is 2x plus x plus x plus x plus x plus x. Alright, so now let's look at this triangle. Let me color it a different color. Make it this nice pink color. Okay, let's look at this triangle. Now again, we have a 90-degree angle, right? And it shares an angle. It's kind of hard to draw, it's kind of small. But it shares an angle, A, with the big triangle. So again, by AA, similarity, angle-angle similarity, we know all three angles are equal, so these are also similar triangles. But in this case, the long side is x, okay? But the ratio of the sides has to be the same. So if if the long side is twice the short side, then this short side down here has to be half of the long side. So this is actually x over 2, okay? And that's the key to this problem, is recognizing that the length of this side can be broken up into a multiple of x's. Okay, so we have 2x plus x plus x plus x plus x plus x plus a half x. Okay, so we have basically 7.5 x's. So I'm going to write that 7.5 times x is equal to 3 times the square root of 5. Alright? And we could write that as 15 halves, just to work in fractions. And so, oops, I wrote 15 twelfths. My. So let me get rid of that. Alright, it's 15 halves. Alright, so let's solve for x. Well, that's pretty easy. We can just multiply both sides by 2 and divide by 15. So x is equal to 6 times the square root of 5 all over 15. Okay, or I can rewrite that. I can divide both top and bottom by 3. And so that'll be a 2, and this will be a 5. So that's 2 square root of 5 all over 5. Well, now what do we want to find? We want to find the combined area of 5x, or 5 squares, 5 of the 5 squares. And the area of 1 is x squared, so the area of 5 is 5x squared. Alright, so let's take this and square it, and take it times 5. So 5 times 2 square root of 5 over 5 squared, right? That'll give us our answer. So let's work that out. So 5 times, if we square inside of here, we get 4 times 5 all over 25. Okay. And then we can see you have 5 times 5 up here, and that'll cancel with the 25. So you end up with 5x squared is 4. And our units are centimeters, so that's square centimeters. Whoops, not cubic centimeters. What am I doing? Square centimeters. Alright, so that is our answer. Pretty tricky, huh? And it all comes down to, to knowing how to find similar triangles, and knowing that the sides are proportional. And also, well, actually we didn't have to use this, these parallel lines. I mean, you could, if, you can show that, I mean, this, by definition of a square, these lines have to be parallel to each other. This bottom hypotenuse and the line that's running across the top of these squares. But it turns out we really didn't need to use that, because we knew this is a 90-degree angle, and then we know that this side has to be equal to the angle of the big triangle, because obviously the same angle, and the same way over here. So, so there you go. That's the answer, 4 square centimeters.